Thanks, everyone. Now, this is the last sessions, one of the last sessions of the day and of the conference. Thanks for coming in and listening to our session. I'm Akka Mannion, engineer with Capital One, and my co-presenters here today are Raja, another engineer, as well as Andy Bonham, who is from our architecture team. Quick blip about Capital One for some of folks who may not know about Capital One. Capital One is a diversified bank holding company. It has operations in US, UK, and Canada. We have more than 65 million customers and about 45,000 associates. We're a Fortune 500 company. Headquarters is in McLean, Virginia. A little bit about the history of Capital One. It's one of the relatively younger banks. There are banks that have been around for decades and some centuries, but we've been around for a little over 20 years. Our IPO was in mid-90s, and over the years, what used to be a monoline credit card company, we have become a diversified bank holding with consumer banking, commercial banking. We also offer auto finance, home loans, and other products. Last few years, a lot of emphasis on the tech side. We are all into cloud. All our deployments are on cloud. We are embracing APIs, microservices, and containerization in a very big way. And also, we are big into open source, both using open source and also contributing to the open source projects. The talk today is about our kind of lessons learned and how we went about the journey of building our very first application using the Reactive framework. This is for a credit card fulfillment process. So when you go and apply for a credit card and when you get approved, then we have to have a certain set of things that needs to happen. The card needs to be mailed out to you so that you can use the card. There are some additional disclosure letters that needs to be sent out. You have to be set up in the system of record for getting your statements. You have to be set up in the reward system so that you can earn the rewards and use the rewards. So there is a bunch of things that needs to happen once an accounts get approved. So our system or our application was to build this fulfillment process. There was a very tight deadline, as it's not surprising, like all of us have been there on, it needs to get done on a certain day. So there was a very tight deadline that couldn't be moved. Again, we were dealing with a very new team. So this was a team that was kind of getting formed at that point of time. It was September of last year. We had 2 associates who are new, who just joined the team. We had 2 contractors. And all of them none of them had any reactive programming experience. All of them had worked in Java in the past, and they were familiar with the Capital One procedures and processes. But other than that, none of them had any experience working with reactive programming. So the mission was, as I said, is to build this fulfillment system. And due to the beauty of the microservices, we are in the modernization of our monolithic decisioning platform. And in the past, we can go to our monolith and in one place, like few tables, get all the details that we want. But in the microservices world, all this information is spread out across multiple microservices. So all these calls have to be made, API calls have to be made to gather this information. And then we have to update all the downstream systems. So that was one of the big things that we had to go through was the sheer number of APIs that we had to call. The main thing for us was we got a lot of encouragement and support from our leadership team on go ahead and try out anything new, right? So the team kind of started working on some of the prototyping with Reactive, but we got a green light to go ahead and try it out. But the thing was like, hey, there is a deadline, need to make sure that you meet the deadline. So that was really worked in favor for us, is to have that backing to support us in kind of our journey building the Reactive application. So why reactive? For that, I'll hand it over to Andy.
Thanks, Doug. So a lot of the legacy applications that we had dealt with used a lot of kind of blocking and sequential type processing. So we wanted to try out the asynchronous type approach and see how we can get down the processing time, see how many of those calls that we can do in parallel. There also were requirements for the service to be highly responsive, as there's a user on the at the end waiting to see the response. So there was a lot of support for this particular project to try it out as a pilot. Where it felt like the use case was a good one. There was a need to aggregate a bunch of data, do a lot of that asynchronously, and so that's why we chose this project as that pilot. So a lot of concepts I'm going to hit on now. You guys have probably heard by now at the conference, so I won't go into them for too much. But so we all know the challenges of a monolith application. There's a lot of dependencies. It can be hard to change. You have everything tightly coupled and all kind of deployed as one thing, and that obviously brings a lot of challenges. With microservices, that changes that approach, where you take the services, you break it out by domains, and you have them focus on doing one thing and doing it well. They're independent, they're decoupled, you can deploy them in their own containers, and they can also be ephemeral, right, where you can have instances scale out and then scale back down based on the workload. But are they a silver bullet? In some ways, they're just kind of squeezing the balloon of complexity, where while you're making the services themselves simpler, you're adding more complexity in the overall distributed system. So you need to rely on tools like the DevOps automation and monitoring to help you manage that complexity. So with reactive architecture, you can compare it to some of the more legacy blocking type patterns that you would see in older applications, where in some cases there may be an orchestrator, and in order for it to call service, say there's 3 services, in order for it to call service B, it has to wait for a response on service A. And that's obviously not good because there's wait time there, and the total processing time is the wait time for all the services added up together. There's also coupling there as well. With reactive architecture, you can see on the right-hand side there, you have the event stream that's decoupling the services from each other. And if you go more of a choreography type pattern, the logic that actually controls the flow is within the services themselves. So you can kind of think of it as someone like a marching band. Before they do their thing, they know what they're going to do ahead of time. Orchestration's not bad. There may be some cases where you need to do orchestration. You just want to do it in a non-blocking way. And through some of our experiences, we found in some cases you might actually need a hybrid, where maybe you need to do some reactive kind of distributed flow control and also some orchestration. So maybe you have you take a reactive approach kind of within or between services, and then orchestration within. There's a blog out there on the Capital One Dev Exchange that goes into this a little bit more, in case you guys are interested. By now, I think everyone's heard of the Reactive Manifesto, responsive. You want your application to be responsive even during failure, resilient. If it fails, you want it to be able to recover quickly. Message-driven is where you break your application into domains, and you have boundaries, and the messaging is what allows them to communicate but stay decoupled and do so in an asynchronous fashion. Elastic, you can scale out, scale back based on the dynamic workload. So some of the benefits with reactive architecture, you're taking better, using the resources you have available to you better. You're doing more stuff in parallel at the same time. So you're getting better resource utilization. Also, because things are decoupled, it's more extensible, so you can plug new services in. That also helps out the development teams that are building the business capabilities. They can focus on the individual services and plugging them in and out. As we mentioned before, you'll also see faster processing times as requests can now be run in parallel. But as with anything, there are trade-offs, right? Where asynchronous programming can be a mind shift. So for the first time that you're doing it, you kind of think of it similar as recursion, where what you see in terms of looking at the code may not be obvious. You have to think through what would be true at a certain point in time. And then if you also take more of a distributed approach to a choreographed approach with your flow, that then becomes kind of spread out and embedded in the services. So you don't have a central orchestrator to go to see the flow. So there's a bunch of ways you can build reactive applications. There was a blog post from Pivotal, I think it was Dave Sire wrote it, and it was really good. And so this isn't a comprehensive list of everything that's out there, but some of the at least common ones that we found. And we categorize it into 4 different buckets. You have JavaScript libraries that allow you to build kind of reactive front-end applications like Angular, React, or Node.js. Then there's languages that can support reactive models natively, so Scala, Clojure, Go, Java 9 and Spring 5, which recently came out, support have native reactive capabilities. Then there's reactive layers that run on top of the JDK. Akka and Vertex are probably some of the common ones you've heard of in this conference. And they all implement what's known as the reactive stream spec, which allows them to be interoperable. So they implement standard things like back pressure. And the 4th bucket were the reactive extensions, and this was actually started by Microsoft with their rx.net. And then Netflix, around 2012-13, wanted to take that approach and build it for Java and came up with RxJava, which also implements the reactive stream specs. So you'll find some cases where you can use these things together, like you can use RxJava with Vertex. So in a lot of cases, these different things complement each other. But for our use case, we decided to use Akka. We felt it was fairly mature. You may have also seen Fred Crable's talk yesterday in auto finance. So they went before us and they had a lot of success with it. So we wanted to start with that for this pilot. I'll now hand it over to Raja.
Thanks, Andy. Hey, so for our reactive fulfillment process, the technologies that we used mainly are Lagom, Akka, and to some extent we also use the clustering part. So Lagom, I really liked it. It's reason being, when you are developing an application, it's really easy because in one command your Kafka and your Cassandra is up in your local, so you don't have to start your Cassandra or Kafka cluster in your local. It's already up with a single command. And then if you want to try out some POCs, it's a good place because there is a hard deployment feature there, so you don't have to start and stop your server. You just change your code. It will take care about all the stop and start of that server. Akka is mainly, we created a couple of actors based on our needs, and I'll go through it. What are all the actors that we created in our use case? Clustering, we started, implemented the clustering part. We implemented, but we end up having a single instance. We implemented the sharding mechanism within that single instance, but due to time constraint, we could not able to extend it into multiple nodes. So the main advantage of Lagom that we benefited is like you minimize the development speed. Sorry, maximize the development speed. created a couple of POCs within a short time span. We had to create a few REST endpoints. It was super simple. It's like 2 or 3 line of code, and then it will be done, right? I mean, you can start exposing that REST endpoint using Lagom. Later on, we created another project where we implemented the CQRS and event sourcing pattern, and where we leveraged the the Lagom framework there as well. So this is the high-level context diagram. It's more simplified. Of course, it's not that simple, but on a high level, what we were doing is like during the fulfillment process, we got that feed, hey, the card booking process is done. Now you need to store the data in somewhere in the data store. So once we received that feed, what we had to do is like we had to call multiple APIs. Let's say, for example, the app capture API. So with that feed, what we had to do is like get the details from the app capture API, and parallelly, make a call that it's more of an identity actor, which will get the details like how that applicant was verified. So we got all the details from that identity actor, and then at some point of time, we had to merge all those things. Although it's like super simple, but it's not that simple. Orchestration was a bit complex. So at some point of time, we had to merge all the upstream information, and then based on the status, we had to make some decision. Hey, all the information I got, now I need to go and make a call research API. Research API is more of an it's like getting more details how that customer is verified. So once we got all the details, the end result was to store all those information there in data store API. So that's what we did. Now the challenges with this application was we created that REST API using Lagom and backed by Reactive System, right? So it can easily support 500 TPS, but that was not the case for app capture API or identity API. Those are traditionally, the Spring-based API, and those were supporting like 30 TPS. So somehow we need to adjust that one. So what we did is like within our cluster, we created the single instance of each of those actors. Like app capture actor was a single instance. So we got all the information in our Saga actor, and then when we are sending those information to one of that app capture actor, there was a message queue inbuilt in that actor. So it was taking all the messages and queuing all the messages there in that actor. And there was a tick that we implemented. It was like, based on the TPS requirement that the downstream was offering. And then based on that tick, we were calling the downstream API. So it's like, it's coming like 500, and then when we are sending, it's more of an 20 or 30 TPS. Moving on, and here also one more point is like, we build an automated retry mechanism. It's more of an config driven. So let's say one of the API, like identity API is down, or maybe it's in an weird status like 500. Now what we decided is that can be, we can give and retry one more time retry. It's like, hey, something happened in that API, let's try one more time. So we configured that part in our code. So it was more of an automated way of calling one more time. And let's say after 3 times, even that doesn't work, we consider that one as a failure and stored that record in our Postgres instance. So there was a separate application called retry, which was more of a Spring Boot. What it does is like, next day it will pick all the records from that Postgres instance, and then post it to the REST API one more time. So that's how the whole process is working now. So these are all the capabilities that the current credit card fulfillment process is having. So it's more of getting all the details from different API, and then updating the information in data store API. We implemented the cluster mechanism, but it's more often in a single node right now. And there is a capability of retry automatically within that application. Now later we developed one more application with Reactive System. It's called Correspondence. This use case was, let's say the application is coming, right? And for some reason, we cannot offer the credit card to end customer, right? So there is a requirement, right? If there is a decline, we need to send a letter to end customer. So this is the scenario which we implemented using Reactive System. So what we did here is that, let's say the fulfillment process is saying that, hey, I cannot offer a credit card for this customer. So we receive that feed. And once we receive it, it's more often we dedicate that request to an actor. So what that actor does is like, it's more often we are implementing the event sourcing pattern there. So we created a couple of events there, and we publish those events in our Cassandra store. So it was more often the right side of that, the CQRS pattern. And then at the same time, we are making call to that app details API, get all the details, because when we need to send a letter, we need to get the application name, application address, all those stuff, right? So we get all those details, and then once we have all those details, we are making a call to send letter API. Now in the right side, now there could be scenario like, for some reason, the send letter API is down, but somebody wants to know what's the status of that letter, right? So the read side will give you that capability, right? So somebody will come and query in the read side and get the status of that letter. Also, it gives us, we extended some more, capability here. So what we did is like, let's say for some reason, the send letter API was down, and we could not make a call to send letter API. Now, we still need to do a retry, right? So next day, the same information is coming from a retry app. Now, there is no point going back to app details API and grab all the details, because we already made a call and that was successful, right? So what we did is like, we stored all the information in our right side, and then we reconstruct that state. And once we have that state, we can make a decision that, hey, this call is already done. There is no point making that call. And then we will go straight forward and make a call to the send letter API. Apart from that, we also developed some reporting capability along with this application. And moving on, this is a sample code how we implemented the replay capability. So once there is a command coming to, let's say, initiating that get correspondence request. So we created some events, and then we published those events using that persist method. It was really simple. It's like 1 or 2 liner that we need to write, and everything will be taken care. And then when you want to replay all the records, what you need to do is like you need to pass that persistence ID. Once you pass that persistence ID, it will start replaying all the events that you stored for that persistence ID. So you can very well reconstruct the state from that event and then make a decision from there. Now I'll hand it over to Tiago.
So to wrap it up, the lessons learned, again, Andy mentioned it in the cons of reactive programming, just the learning curve, right? The teams, the people who have been working on it were mostly familiar with the synchronous way of building applications. So to kind of think about in the asynchronous way was a little bit of learning curve. And again, with the actor model, it's kind of like a little bit of mind shift on when you've been thinking on like objects and methods to actors and messages. So once the team kind of got hold of the constructs and the idea, then it was easy to move on from there. So there is a little bit of learning curve. So for people who have been kind of working on the traditional synchronous way of building applications. Again, kind of related to that, unit testing and performance testing was also was a little bit difficult initially. Again, thinking about like in future what will happen, how do I make sure my unit test will pass based on something happen asynchronously. Throttling that talked about, our application was able to handle a much higher throughput, whereas we are constrained by our downstream system, so we had to do something within internal to our applications to kind of do the rate limiting. But like the last presentation from Colin showed about like back pressure. So things like that, Akka streams are some of the better ways to implement that. But for our use case, based on our time constraint, we have to do with an internal queuing mechanism that we put in place for that. Again, we started out with a grand vision of like having like Akka persistence and Akka clustering for our application, and again, due to time constraint, we kind of had to drop them. And like fortunately for us, our use case, we didn't have to have the persistence. We could kind of retry from the beginning if something fails. So we were kind of lucky enough from that point of view to not need it for that project. But the next project, the Correspondence, that we kind of took the learnings from our previous project, and then where we implemented Akka persistence on top of that CQRS. So it's kind of our incremental learning in our journey to kind of building our reactive applications using Akka. So that's our presentation. Any questions? Are there any questions?
Back there.
I had a couple questions. How did you decide on the granularity of your actors? It looks like they're pretty coarse-grained, like each microservice is an actor. Were there any decisions there where you could have maybe broken it down and had smaller actors, where each service is kind of a collection of actors?
I'll take that. So basically what we did was the easiest thing was to wrap each our service with an actor, and that's kind of what we did. There were a few APIs where we could have had one actor that could have called multiple APIs, but the approach that we took was to wrap each each API or each microservice with an actor.
Right. And then you touched on a couple things just now that you didn't manage to get to because of time constraints and that. What else, where do you want to take this in the future? Maybe continue to evolve it and add things to it?
So the Akka streams are definitely something that that we are interested in looking at. It seems to be, there's a lot of things that we are like moving to more like an event-driven systems, and feel like Akka streams would be something interesting for us to look at.
Hi there. I had a question about, I saw on a slide that you mentioned you started out with a streaming application, but then in the middle switched to batch mode. Can you expand more on that?
Yeah, so this was supposed to be part of the card application process. So while you are online, you kind of fill through your form, submit, and then hit submit, and then the decisioning happens, you get approved, and then as part of, after you're approved, then there is a real-time feed of getting you set up in multiple systems. What happened was in the middle was due to one of the APIs not being ready, we had to kind of like, or due to the sync issue of some data being available upstream, we had to like do it as a batch so that it's not like real time. So it's a day behind. But that API has been fixed, so shortly we'll be moving this as part of the real-time stream.
Okay, and do you use or will you use for your event sourcing?
I'm sorry?
What do you use for it looks like you had your event stream, and what's the persistence mechanism for the event stream? Is it Kafka or something like?
So yeah, I mean for event sourcing, we are using Cassandra as our event store and storing all the events there.
Can you give us a sense of what time, how long it would take you guys from starting the team for people you said to the point where, kind of the milestones?
So as I said, the team started in September. We started actually like end of October is when we got the intent or the use cases kind of coming into the team. So we got like September and October to do kind of like continue some of the POC work that we were doing, and then our release was in early March. Cool. Thank you.
Thank you.
Thanks.